Okay. Now it says three identical smooth spheres P, Q and R, okay, are lie and rest on a smooth horizontal surface. Okay, so there's the three of them there. Okay, of a table with their centers in a straight line, so their centers are all lined up, okay, and they're all the same size. Q is between P and R, so we have P, Q and R. Sphere P is directed towards sphere Q with a speed of 2 meters per second. And then sphere P is directed towards Q with a speed of 2 meters per second. Sphere P collides directly with Q, and then Q collides directly with R. Coefficient between each collision is 3/4. Show that P strikes Q a second time. Okay, so what we're just going to write down is labeling is very important, alright? So collision PQ, and write down your two equations just at the start. M1U1, M2U2 equals M1V1 plus M2V2. This is what's called a PCM, Principle of Conservation of Momentum. NEL, Newton's experimental law, which states that V1 minus V2 equals minus E times U1 minus U2. Now, we're going to start off with PQ. Okay, PCM for PQ. Now, PCM is, they're all of mass M, aren't they? To say that? They're all identical, so let's just call them all M. Okay, so we're going to go MU1, which is going to be M times 2 plus M times 0 equals MV1 plus MV2, where V1 represents the speed of P after the collision, and V2 represents the speed of Q after the collision. Okay, so we're going to get is 2, cancel off all the M's. V1 plus V2 equals 2. Okay, then we're going to do NEL. And we get is V1 minus V2 ends up to be minus 3/4 because it's E, and then U1 minus U2, which is going to be 2 minus 0. Then what we're going to get here is V1 minus V2 equals minus 3/2. And now we have two equations ready to go for the simultaneous equation. So we have V1 plus V2 equals 2. We're going to get 2V1 equals a half. V1 therefore equals 1/4. Substitute V1 into this equation here. So 1/4 plus V2 equals 2. V2 therefore equals 2 minus 1/4, which is 7/4. It's known that both particles are moving in the same direction after collision. So V2 is moving with 7/4. So Q is moving with 7/4, and P is moving with 1/4. Okay. Next one you gotta do is collision QR. So collision QR is we're going to do PCM, Principle of Conservation of Momentum. It's going to be M times 7/4, because that's the velocity of Q. So just draw a quick diagram maybe here to show you what we're doing. It's going 7/4 on the way in, the other one's not moving, and then on the way out we can call them V3 and V4 after the collision. So M times 7/4 plus M times 0 equals M times V3 plus M times V4. And then we're going to cancel out the M's. We're going to get V3 plus V4 equals 7/4. And then we're going to do NEL. NEL, which is V1 minus V2 equals minus E into U1 minus U2, which is going to be minus 3/4 minus 3/4 7/4 minus 0, because it's 7/4 on the way in and 0 is the speed of U2. Such that V1 minus it's not V1 minus V2, it's V3 minus V4. That's what we're doing here. So V3 minus V4 is minus 21/16, which is the same thing as minus 21/16. Okay. Put the second equation underneath, and we get V3 plus V4 equals 7/4. Add directly downwards. 2V3 ends up to be 7/16. V3 ends up to be 7/32. Okay, now guys, in this question here, you didn't actually have to worry about V4, did you? Why didn't you have to get V4? Because you automatically know during a collision it can't catch itself back up. If two particles collide and one of them moves off, unless there's an outside force, the particles can't catch up again. It'd be like hitting a white ball off a red ball in snooker, only to see the white ball catch back up again. It just doesn't happen. So in this question, you didn't actually have to target V4 at all. So this is exam technique right here. You only actually have to target V3. Okay, because you're comparing to see if the first particle catches up with the last particle. So you want to know, is V1 faster than V3? Well, V3 is 7/32. V1 is 1/4. 1/4 is 8/32. So another collision will occur. So another collision occurs as V1 is bigger than V3, or 1/4 is bigger than 7/32. Okay, a smooth sphere of mass m moving with speed u collides with an identical smooth sphere B moving with speed u. Direction of the motion of A before impact makes an angle 45 degrees with the line of centers of impact. The direction of motion of B before impact makes an angle 45 degrees with the line of centers. The coefficient of restitution between the spheres is E. Find in terms of E and U the speed of each sphere after the collision. Okay, so what's important is a before and after picture. Okay, so you can do 4 spheres, okay, and all I like to do is a before and after picture of each one. Okay, so top is before and the bottom is after. Now before, what we had here was it's going up with a speed u, and that means it's at 45 degrees, which means that's u. It's going to be u over root 2, because it's going to be u cos 45 and u sin 45. So this one here is u cos 45, which is u over root 2. This one here is u sin 45, which is u over root 2. Now, this is particle A. Particle B is moving in the opposite direction. So it's also going to have 45 degree angle and u. So it's going to be u over root 2 to the left, and u over root 2 going upwards. Okay. Now after the collision. Now what's the rule about after the collision, lads? What's always maintained? The J component is always maintained. So what we will assume is, I have no idea what direction they're going to go in after the collision. So what I always tend to do is, I always tend to assume that's going diagonal up and right. Everything's positive. Okay? And if I'm wrong, I'll get a negative answer. So what we know is that this velocity here is going to be u over root 2. What we don't know is what this is going to be. I'll call this one V1. And then on the other one, I'm going to do the exact same trick. I'm going to have them both going up and right, even though that's probably going to be wrong. So it's going to be phi 3, and then going up is u over root 2. So we'll have a good piece of information here. Okay. Now, what we're going to do is we're going to do PCM, Principle of Conservation of Momentum. I'm going to put an I signal here. The I signal means I'm doing along the I axis. So m1u1 plus m2u2 equals m1v1 plus m2v2. So I'm going to get is m times u over root 2 plus m times minus u over root 2, because it's going in the opposite direction. So remember that b is going in the opposite direction to a. Okay, and then we're going to get mv1 plus mv3, because they're identical particles. The m's cancel. Oh, sorry, phi 2. And what we're going to get is phi 1 plus phi 2 ends up to be 0. And then we're going to go for Newton's experimental equation, NEL. Okay, and it's going to be along I. Now, along the I-axis we have phi 1 minus phi 2. Okay, phi 1 minus phi 2 ends up to be minus e into u1 minus u2. u1 is u over root 2 to the right, minus u over root 2, that's going to the left. So there's a double negative there. So we're going to get phi 1 minus phi 2 ends up to be, what's it going to be? It's going to be minus e bracket 2u over root 2. Now 2u over root 2 is the same thing as 2 divided by root 2 is root 2. So it's going to be minus root 2 eu, which is phi minus phi 2. Now that we have both equations ready to go, NEL and PCM, we can add them together. And what we should get is 2v1 equals minus root 2 EU, and v1 ends up to be minus root 2 EU all over 2, which is going to be minus EU over root 2. So phi 1 is minus EU over root 2. Phi 2 is actually minus phi 1, opposite direction to v1. So phi 2 is going to be EU all over root 2. Okay. What happens here is the following, guys. What happens is we've got 10 out of 25 for this far along, mark wise. Phi 2 is going diagonal right up after collision. So sphere B is going diagonal right up, and sphere A is going diagonal left up. The question specifically says the speed. Speed means Pythagoras' theorem, not velocity. It wants the overall, it wants the hypotenuse or the diagonal of the motion. So what we're going to do is we're just going to quickly do a quick triangle for both of them. So this one's going left and up. It's going diagonal. Sorry, the arrow's going that way. Okay. So what we get is a EU over root 2. Going to the left. Going up, it's U over root 2. And that's for particle A. For particle B, it's going diagonal right up, which is going to be EU over root 2, U over root 2, and then Pythagoras' theorem both of them. Okay? Even though they're actually going to result in they should result in the same answer, shouldn't they? Okay, so what we're going to get is velocity of A, and speed of A will be in brackets. We go U over root 2 squared plus EU over root 2 squared. Okay, so what we should get here is we're going to get a U squared plus E squared U squared all over 2. And if we break this up, we can get a square root of u squared over 2 into 1 plus e squared, square root the outside, and you can get u over root 2 into the square root of 1 plus e squared. This speed is the same for both of them. Okay? Speed of A and speed of B are exactly the same. Okay, so they're the same thing. Now, what we want to know next is what is the, if E equals a half, show after the collision that the angle between the directions of motions of each sphere is tan inverse 4 over 3. Okay, so we can go back here. And it says the angle between the directions of motions of the two spheres. So what basically it wants is, if I was to join the two of these together, it basically wants the angle in between. So that's what it wants there. Okay, it wants this angle here. Now, what we can do is we can replace E is 3/4, right? Oh, sorry, E is a half. So if E is a half, this here will become U over 2 root 2. This one here will also become U over 2 root 2. 2 root 2, okay? And what we could do here is, I'm going to label them, they're both actually a tan alpha, aren't they? They're both actually the same angle. So let's call it alpha, and this can be 180 minus 2 alpha. Now, because we don't really want any rounding off going on here, so that's a problem. So we're going to use the tan A minus B formula. Does anybody know the tan A minus B formula? Or yeah, it's going to be tan A minus tan B all over 1 plus tan A tan B. Now let me show you how that's going to come into use now. We know that tan alpha is going to be tan alpha is going to be u over root 2. Sorry. Tan alpha is u over root 2, which is the opposite, divided by u over 2 root 2. The u's cancel. 2 root 2 ends up to be over 2, root 2. So tan alpha is 2. Okay, that's grand. Now that we've found out what tan alpha is, we want to find out what tan 2 alpha is. What's tan 2 alpha? Tan 2 alpha is, there's a formula for that. 2 tan alpha over, trying to think now. Yeah, 1 minus tan squared alpha. Okay, so look, tan 2 alpha is going to be 2 times 2 over 1 minus 4, or 1 minus 2 squared, so to speak. And it's going to be 4 over minus 3, which is minus 4 over 3. We now have to find out this angle here. Okay? Sorry a second. So many ways. Lads, so I'm basically saying A is 180, B is 2 alpha. So it's going to be tan alpha 180 minus 2 alpha. Now, what's tan 180? 0. So it's going to be 0 minus 4 over 3, and then it's going to be 1 on the bottom, minus 0 times minus 4 over 3. So it's going to be that 4 over 3. Is that what I wanted? Yeah, perfect. So it's going to be 4 over 3. Which equals 4 over 3. So the angle in between them is 4 over 3. The tan of the angle in between them is 4 over 3. Okay.